Okay, let's see. I see a few familiar faces. I don't know a lot of you. Move this out of the way. So I look forward to getting to know all of you. My name is Damon Sist, for those of you that don't know me. And I've been teaching mechanical engineering technology here for 8 years now. 9 years. So I've taught this class since about, I don't know, probably the second year I was here. So I've been teaching about 8 years. It's changed a little bit over that time. Hopefully it's improved and not gotten worse. If you're wondering about the video camera, I'm recording this because there's another professor that's starting to teach this class. It's helpful to see what someone else does, kind of what examples they use, what unique things they have. So I'm recording it for that professor. If you guys want it, you can have it. I don't think it's all that valuable. It's more just so that the other professor can kind of see things. Here you go. Are you on this computer on the end? No. Okay, well, it looks like that computer's available. All right, now, I should have gotten here about 30 minutes ago for the computer to log in, so I've got to make up something to do for 30 minutes. Okay, so we'll do something. I have posted the syllabus. I see that most of you are already logged into the computer. Please check your Blackboard account and make sure it works if you haven't already. In fact, just go ahead and log into Blackboard if you can and bring up the syllabus, since I can't seem to bring it up on my machine. Of course, when we're all hitting Blackboard at once, it'll probably just appear. We'll see. I use Blackboard extensively in all of my courses. You will absolutely have to have access to Blackboard to get through this class. Okay? So make sure that you can get it. If you can't, I'll help you figure out what's wrong and get you to the right person so you can get your account activated. This class, if you've been in class with me before, this class is pretty different from all of my other classes. This is the most hands-on, the most practice-based class of all that I teach. Okay? I teach much less theory in this class than I do hands-on practice. Okay? So, if you're used to my teaching style in other classes, you may be a bit surprised at this. The CD that I handed out, I will not be in violation of copyright law. That is a copy of a copyrighted CD. Okay? You have to buy that CD. You don't buy it from me, you buy the original. I have posted a link on Blackboard, and I'm sorry that this class costs a lot, but believe me, it is well worth it. The book that I use used to be cheap, and I guess everybody caught on that this has both discrete control and continuous control on it. Everyone started using it. So anyway, to help you out, I have posted the ISBN number in the syllabus. So if you open up the syllabus from Blackboard, you will see the ISBN number. You plug that into Google and shop for the lowest price. Okay, that way you don't get ripped off at the bookstore. Right? It's still a relatively expensive book. It used to be cheap. I don't know what happened. I apologize for that. I wish I could find one that was better. But what I really need is a book that covers both discrete and continuous control. This is the only one I can find that does it halfway decently. Plus, I'm familiar with the book. I know where the mistakes are, and I can point them out and help you correct them. Okay? Paperback edition is probably a little cheaper. Sometimes you can find international versions. Those are cheaper. Okay? So, I'll leave it up to you to shop for the book. All right. The computer slowly logs in. I guess by the time it logs in, we'll be ready to leave. Right? Anyway, the CD that I gave you is a piece of software called Logix Pro. Now, how many people have heard of a PLC? Anyone heard of what a PLC is? Okay, what does it stand for?
Programmable Logic Controller.
All the WTs say together, Programmable Logic Controller. MBT's like, what? Programmable.
I didn't get one.
I ran out of them. I'm sorry.
Okay.
I've got several more people. If you didn't get a CD, please see me after class. I'll try to find some time, but we'll make some copies. Okay. Probably what I'll do is I'll just bring it to you next class. I just need to know how many people didn't get one. Okay. Thank you for telling me. But you will need to order this CD. Okay. You cannot pass this course. You will fail this course unless you get this CD. Okay. And that may seem a little bit harsh, but the software is actually well worth it. Okay. PLC stands for Programmable Logic Controller. Basically, it's an industrial computer. And that's a lot of what we're going to learn about this semester. Okay. Why don't we use Windows to run nuclear power plants?
Could it crash all the time?
Do we want Fukushima every month? Probably not, right? It's not reliable, right? I mean, it's okay for home use. There's nothing wrong with it. It does some really neat things. It's a very handy tool to have, but quite frankly, it's buggy and it crashes. It's just the nature of the beast, right? PLCs are not like that. PLCs are programmable logic controllers. They're computers, essentially, that are ruggedized. They don't run Windows. They don't run Linux. Well, some of them do. Okay, by and large, they don't run, they run their own custom operating software or operating system. You don't hook up a keyboard and a monitor to them. You program them via a laptop most of the time. And once you turn them on, they do what they're supposed to do and they don't crash. That's why you pay a couple $1,000s for a PLC that has the capabilities of 386 computers, okay? Because it's so reliable. Gotta get this computer to respond to me. So we're going to learn a lot about PLCs. Now, the first chapter, well, another reason I like this book is because the very first chapter in the book deals with safety. The safety is one of the most important things. When you're programming a controller, you got to think, what are you programming this controller to do? You're programming it to control some system, usually a very expensive and very dangerous system. Okay? We're talking about things that could easily kill a lot of people very quickly because there's so much power involved in these machines. Okay? Or could easily crash the machine, damage it, where the company loses several $1 million because that's what the machine costs per does. Okay, so safety, the human life, of course, is by far more valuable than the machine. But the machine itself is important too. You want to make sure that you keep your jobs, you want to program the PLC properly and not make mistakes. So anyway, hopefully I can help you introduce you to PLC programming and get you started on the right track. What else can I talk about before I get my presentation over? So we're going to start with safety because that's the most important topic. That's the first chapter of the book. The homework, there are homeworks, there are projects, and they're all on Blackboard. Okay. Usually what I do is I have a project about halfway through the semester where you actually program a PLC to control some type of machine, and I'll show you what that will look like in just a moment. But this semester we may decide to do something a little bit different. I can't promise you this yet, but we had meetings in West Lafayette, me and the other faculty, this past week, and when we went out there we were talking, and Professor Turner, you guys know Professor Turner, right? He's Turner, right? Well, he had a great idea. He said, you know what would be really neat if we could, we're trying to get people interested in Purdue and let them know that we're here, and attract other students as well. And he said it would be really neat if we could have a Christmas display. Okay, so the idea is that we have some animatronic, I don't know, some kind of display that moves and you can actually interact with. So the public could come in, we'd have controls set up, Christmas decorations everywhere, so they could control something. So we were just brainstorming. We thought, it'd be cool to have something big on the roof of this building. So you've got the controls down in the parking lot. People drive in, they can control a joystick. I don't know, maybe it's a video game. Maybe, I don't know. Okay? I don't know what this looks like. But something to revolve around Christmas, because that would be the theme that time of year. And something that lights up and gets attention. Okay? So we could contribute heavily to that kind of project, because there would be a lot of controls embedded in that sort of thing. Okay? So we could really do a lot with it. The only problem is, I don't know how many of you are actually artistic. I'm an engineer. I am not artistic. Okay? When it comes to artists, being an artist, I would starve, okay, if I had to make my living that way. Okay? What I have found out is that we have a lot of really good artists here. They're all in the CGT department. Okay? So if we can get them to work with us and do more of the aesthetic design, we do the controls design, maybe we can get a manufacturing class or a senior project or something where some of the building done by them. That might help us out a lot and make this project possible. But if we can't get the CGT help, I don't want to bother with it because I want to make sure it looks good when we're done. Okay? Now, not that there's probably some artists in here that could do it, but you probably don't have enough to go with. Okay? Because with a class this size, which I believe there's 22 students in here, 11 METs and 11 ECETs. The class this size, we will have multiple teams working on whatever the project is. Okay. Let's go through the syllabus now that Blackboard is up. We'll start there. Okay, do you have an idea of what you're in for this course? Now, one thing, let me just tell you a little bit about myself while the syllabus is loading. I like teaching, and the reason I like teaching is because I want you to learn. Okay? What fulfills me the most is when I see the light come on in your eyes. Okay? You don't understand something, you bang your head against the wall. I tell you something, you try it, it works, and you're like, this works, this is neat, this is fun. Okay? That's what I like. So if you have any questions or any problems in this class, please talk to me. Don't wait until you're drowning in this class to ask for help. Okay? This is not an easy class, but it's not a difficult class. It's just a lot of work. Okay? So you have to keep up with the work. And if you don't understand what's going on, you can fall behind very quickly. Okay? Try not to miss class if you can avoid it. If you do miss class, please get with me. Don't just send me an email. Get with me and say, hey, what did you go over? What did I miss? Because sometimes you'll miss a lot. Sometimes you won't miss much. Okay? It just depends on the class. But make sure you get with me. Anyway, here's my, that's an old syllabus. I didn't update it because it's ECET 302. Let me see something. Oh, I know what happened. I updated it and had that one mistake. So anyway, this is MET 284, ECET 302. It's combined class now. The ECETs need discrete control, but you're going to get a little bit of discrete and continuous control. And the METs need both. So anyway, here's my name, here's my email address, my office is upstairs. Excuse me. If you guys know where all the other professors sit, we've all kind of moved up there. And so we're all nestled together. I put the schedule on my office door so you can see when I'm available, but also I went ahead and put it, let's see, here it is. Also put it on Blackboard. Let's see. And this is what it looks like when it opens up. Now the reason I'm posting my schedule here is because I have a long walk to walk all the way up to the stairs just to see when I'm available. So I posted it on Blackboard to make your lives easier. I know most of you probably work, and you can't just come and ask for help at any random time. You don't live on campus. This is a little bit different. You know what? It is right off the screen. Let's fix that. Screen resolution. Unless it's widescreen. Okay. Now you can see my schedule. Okay, so here we are right here in this class. I normally set this up and say arrange hours as needed, not because I don't want to meet with you, because I want to give you as many options as possible. I really don't mind meeting with you. I really want you to take advantage of asking me questions anytime you need help. This space in here, I can't meet with you. I have to pick up my daughter from school. That's the only reason. I'll be back afterwards here. Anytime, of course, that I have a class to teach, I won't be available. And I'm taking a class this semester. I'm going to U of L, and I'm going to work on my doctorate. Hopefully get that done eventually. But I'm just starting this semester, so that's my class, and I won't be here physically during that time. Okay? Now, we're being pushed for some reason to deliver our syllabus and our office schedule to a central location in West Lafayette. I don't mind, that's fine, whatever. And they've asked that we have at least 6 office hours that are scheduled on our office schedule. Okay, I've got way more than 6 hours here that I'm available, and I want you to know I'm happy to meet with you any of these times, but I will probably have to put official office hours on my schedule as well. Now, I didn't want to do that before the semester starts because it depends on your schedule. I want to put official office hours at a time when you'd be more likely to come see me. Okay? So if you have any particular office hours you'd like to see me have, please look at my schedule and tell me, hey, from Monday from 4 to 5:30, I'd like for you to be available. I'd like for that to be, whatever works for you with your work schedule and your study schedule, just let me know and I'll do it. Okay? So try to get feedback before I nail down office hours, but I will keep all of these hours open anyway. Okay, and just send me an email to make sure I'll be here, and I will be here for you, okay? Because I want to help you, I want you to learn. I like this class. I'm kind of a geek that way, but I enjoy it. Okay, let's see. Like I said, here's the ISBN number, so that hopefully you can Google it and save some money. By the way, don't panic. I have posted the first few chapters of the book as well. If you click right here, you will be able to download chapters 1, 2, and 3 in PDF format. And once again, you still need the whole book because that's just a small fraction of what we're going to study this week.
I don't have this class added to my Blackboard yet.
Okay.
I signed up for the class kind of late. I didn't know how.
Okay, I'm not sure how we'll do that, but we'll
Okay.
figure it out. Thank you. Anyone else that doesn't have it in Blackboard, please see me and we'll figure out what we're gonna do. I don't know what we'll do. We'll get it. If you need these PDFs, get with me and I'll put them on a thumb drive. Okay. Or if you can do it with the person next to you, that'd be fine too, whatever works. Let's see. The Logix Pro CD, the CD that I handed out to you, you've got to buy the original, okay? And this is the link to do it. I'm not affiliated with this people. Just when I was panicking having to teach this course, I was looking for resources. I found this one as an excellent resource. The reason it's so good is because there's a couple of big names in PLCs. You've probably heard of Alan Bradley, okay, or Rockwell Automation, and Siemens. Those are the two big names in PLCs. Now they're starting to come down in price because there's a lot of other small PLC manufacturers that are making really good units and competing head to head with them. Okay, so you can buy a $2,000 Alan Bradley, does the same thing that a $100 Automation Direct PLC will do. Okay. Pretty easy to see which one you're going to pick. But Alan Bradley's been around for a long time, just like AutoCAD that's been around for forever in the NP world or NP world. There's a lot of Alan Bradley PLCs out there. And so this software looks exactly like RS Logix, the program that you use to program PLCs that are Alan Bradley PLCs. Okay, so it looks exactly like that. I like that feature because it makes you comfortable with the environment that you use for real PLC. But not only that, it has simulated systems. We have some systems in here, like that unit back there, the blue unit that we're not using yet. We have some units that we could actually program and work on that are real systems. But quite frankly, we don't have the room for all the different systems that you might need to learn how to program. This software includes simulators for about 10 different systems, okay? 10 very good systems. About 10, I don't remember exactly how many there are. So I have you go through and program them so that you learn about programming and how that stuff goes, okay?
When you click on that link, it says it's no longer.
Yeah. Uh-oh.
They redirects you.
You're not even getting there.
Yeah, redirect your, make sure.
Learning bit. There we go. Okay, how do we, I'm sure he'd like to still sell it. Which Pro CD Key Edition now available? This is what we're looking for. So let me update that link. Make sure you get the CD Key Edition. What that means, if you don't buy the CD Key Edition, the license will be keyed to your home computer, and that's it. You won't be able to program it there. The CD Key Edition means you just have to have the CD and CD-ROM drive, and it'll run. Okay, that's the one you want. It is about $50. Let's see. Pricing details: 1 to 4, $46; 5 to 9, $42; 10 or more, $36 each. You guys may want to put your heads together and buy 10 or more. Okay? May work out for you. But I don't know of a way to do that through the school officials. But that would save you $10 a head. Another option, a lot of students have taken this class. If you know someone who's taken it, they'll probably sell you their CD for a low price. And that's completely valid. I have no problem with that. Okay? It's up to you guys what you do. Let me update the link. They changed the one letter. Go. Okay, now it should work. Let's see, anything else in the syllabus I need to talk about? Yes, the grade breakdown, you're probably interested in that part. Homework in this class is 10% of your grade. All the homework will be on Blackboard. There's not actually a whole lot of it. Okay? The first 4 weeks or so, 4, 5, 6 weeks is homework on Blackboard, probably not 6 weeks. But then after that, projects are half of your grade in this class. Okay? Big chunk of it, because I believe in this class that you really have to program to learn how to program. Okay? Midterm exam is 20%, final exam is 20%. So there's only 2 exams total in this class. One at the halfway point, one at the end. Okay, and that's it. If there's bad weather, if it snows, and IUS cancels classes, then we're closed too. Right? If IUS has a main water break, that doesn't affect us. Right? So classes are still on in that case. I will give you assignments on Thursdays at the beginning of class. They are due a week from that Thursday. In fact, I always make my assignments due by 11:59, roughly 12 o'clock at night. That way you can you'll get with me on Tuesday, or I'll give you an assignment Thursday. Then you'll have the weekend to work on it. You come back on Tuesday, right? You can ask me questions if you want. And then Thursday, you can ask more questions and turn it in by 11:59 p.m. Because it's on Blackboard. So that way you've got plenty of chances to ask questions and hopefully learn this stuff. I don't really give very many paper assignments in this class, but if I do, I expect you to use engineering paper and follow the GFSAC format, which is given, find, solve, answer, and check. Okay? I expect you to follow that format when it's appropriate. I'm pretty lenient on the format, but I do want your work on engineering paper. Completed tests, I'll let you see. I'll give them back to you temporarily, but I have to recollect those for ABET purposes. And please don't cheat in this course. I've become fairly adept at detecting cheating, and I will fail you for cheating because I don't like it. Any questions on the syllabus for this class? Yes. All right, well then let's start off with safety, because that's probably the most important topic in the class. Unfortunately, I don't recall. Answer, or if this, I think it's this chapter. Yeah, there it is. This is the one I want. Chapter 01 is the slide that shows that. Okay. Has anyone ever heard of lockout tagging? And what is it?
I'm not going to continue tagging out for our signatures, the way for anything to go to it, maintenance and fixing the time to it. Everybody knows that that equipment is packaged.
Great. That's the procedure. Why do we do it?
Because mostly that's the equipment, you don't want something touching it, really cause more problems or potentially injury.
Well, let's talk about it a little bit and go a little deeper. You guys know Gary Larson, The Far Side? An older cartoon now, but anyway. Here's Arnie. The building has fallen over on him, but he's safe because he wore his hard hat. And that, Arnie, is why we wear hard hats on the job. I don't think a hard hat is going to quite protect Arnie, but that's what it's there. So why is safety important? It's important because accidents do happen. Okay? Accidents are going to happen. We know that, we just don't know when. So let's kind of dig a little bit deeper and try to look at the common denominator for accidents. What is the main thing that's going on in an accident? Let's start off with a decent sized piece of equipment. This piece of equipment is several stories high. Okay, you notice this is a small schematic. It's a rock crusher. Rock center here. There's a large motor that rotates a drum, or you can even drive this with an engine, any type of prime mover. Slings the rocks out, and there's sides that hold some rock. Okay, the rock kind of gets trapped there. And basically what happens is you're slamming rocks into each other in order to crush the rock and generate gravel or something smaller than the rocks that you put in. Okay? Clever idea, because you really don't have any blades to wear or anything like that, right? But it's a huge piece of equipment. If a human being fell into this, they would not survive. You don't want to fall into this. Okay? By the way, this is called a ball mac rock crusher. The reason is because it's a combination of the last names of the two people that invented it. We have highlighted the first parts of the last two names. Put it together. It's the bar mac rock crusher. But that's something you really don't want to fall into. Okay? Why wouldn't you want to fall into it?
Death.
Death, yeah, that's a good reason. How would you die?
You'd be crushed.
You'd be crushed by?
Rock.
Okay, why would the rock crush you? It's a rock crusher.
Because they're moving fast.
Because they're moving fast. Okay, it's not because they're sitting on top of you so much, it's because they're moving fast, right? Okay, why are they moving fast? It's so that the job that the machine has to do can be done, right? But what does the motion of those rocks represent? Think back to physics. Remember the equation for kinetic energy, 1/2 mv squared? Okay. That rock has kinetic energy, right? And what happened? Why did that rock have kinetic energy? It had kinetic energy so the two rocks could knock into each other and break apart, right? If it knocks into you, what has happened? It's been misdirected, right? But the goal was not for the rock to hit a human being, it was for the rock to hit another rock. Okay? And so energy being misdirected is what would cause a problem. Does that make sense? Okay, in fact, the common denominator of all accidents is that energy is misdirected. What happens when two cars collide and you have an accident? Energy is misdirected, right? And fortunately, cars are designed now, instead of bouncing off of each other and basically transferring a lot of energy to the passengers, they're designed to actually crumple. And so that you want the car to be strong, but you also want it to absorb the energy of that impact and not transfer it, not transfer the energy to the occupants in as far as it's possible. So the common denominator between accidents, especially accidents on the job, is that energy is misdirected. That's the problem. So lockout, more generally, is a method of blocking the release of hazardous energy. It's a way of shutting off energy at its source. It doesn't matter if it's electrical, pneumatic, hydraulic. There's many types of energy that we might need to block. Okay? So here's an example. Homer is hot, and so he wants to turn the fan switch on, but his co-worker over here is working on the fan. And fortunately, his co-worker has applied a lock, so Homer can't activate that switch. See, the goal is that these locks block the release of hazardous energy. Does that make sense? Now, it's very common to see these on an electrical panel like this. That's probably the most common, but they exist for other situations as well. So essentially what happens is each worker has their own padlock. And they apply their padlock to the device that needs to be locked out, and they keep the key with them so that the machine can't stop and start while they're working. Fatal 5, main causes of injuries. Failure to stop the equipment. Oh, I'll just make an adjustment while it's running. Failure to disconnect from the power source. Okay, I'll work on it hot, no big deal. I've tried that, it's not very much fun. I haven't been shocked by anything more than 220. But 220 hurts, I've been shocked by it twice. 110 tingles a lot. In fact, I used to work for, a little bit of background on me, I used to work for a company called Amatrans. We're in the Jeffersonville Industrial Park. Worked as a design engineer for them for 4 years. It was a good experience, good people to work for. One of the service technicians there was telling me about his previous training and employment. He was training to become an electrician. He was training with an older electrician, and he said, you know, and by this time, this technician I was talking to, he had enough training. He knew how to use a multimeter. He knew a little bit about electricity. But he thought he'd go, you know, not such a detailed route, and go more the trades route, right? So he asked the electrician, he said, well, how do you tell the difference between 110 and 220? The electrician said, well, you put your finger and your thumb across the poles, and if it tingles here, it's 110. If it hurts real bad, it's 220. Okay, so it was at that point he decided it was time to kind of go back the other way. So anyway, all right. Failure to dissipate or bleed or neutralize residual energy. If there's potential energy stored in the system that can be released, even if the machine is unplugged, it can still release that energy and hurt someone. And the energy can still be misdirected. Accidental restarting of the equipment. This is a big one. When I was a little kid, I remember my mom worked for the post office for all of my life that I can remember. She worked over at the main post office in Louisville. It was really interesting. I've never forgotten this story. As a kid, I imagined it as a big washing machine, a big front-loading washing machine. I don't know what the machine really looked like, but she was telling us, this was before Lockout Tag. She was telling me when I was a kid that a serviceman came in to work on this machine. He got into the machine, he had turned it off, and another worker did not know that he was inside the machine. Okay? They came in, they started the machine up. Okay? The man could have died. Fortunately, he walked away from it with a few scratches. But this exemplifies the need for Lockout Tag. If the machine's not locked out where it can't be started, how do people know that it shouldn't be started? Right? It's common that the person working on the machine can't be seen. Failure to clear the work areas before restarting. Okay, so a lot of times when you restart a machine, you think you fixed it, but you didn't actually fix it, and it's about to throw a power off. Okay? So if you haven't cleared the work area around, then people can get hurt. All right, now for a few more formal definitions. There's something called an authorized employee and someone called an affected employee. They are two different things. An authorized employee, just read it, one who locks out machines or equipment in order to perform the servicing or maintenance on that machine or equipment. Okay, that makes sense. Affected employee, one whose job requires him or her to operate or use a machine or equipment on which servicing or maintenance is being performed under lockout, or whose job requires him or her to work in an area in which such servicing or maintenance is being performed. Okay? Does it make sense? Pretty straightforward. All right. Some more definitions. Energy isolating device. This is a mechanical device is not an electrical device, but a mechanical device that physically prevents the transmission or release of energy. Okay? That's what an energy isolating device is. A control is not an energy isolating device. Just because the machine has an E-stop, a red mushroom head E-stop, that is not an energy isolating device. You know why? Because somebody can come, turn the E-stop, it pops back out, and the machine's live again. Okay? So no controls are energy isolating devices. None of these would be considered appropriate for lockout tag. Okay? Even if they've got a way of putting a lock on it, which I don't know of any decent manufacturers that have such a thing. Energy control procedure. This is what you were probably talking about a little bit earlier. It's a safety program that the employer uses to control energy, essentially, and how you lock out. Each company has their own nuances, okay? And so they have their own details that you need to follow in order to safely work in that company. So it's important that before you try to lock or tag out something in a company, that you have gone through their training program and you know how they do it at XYZ. Okay, there are many different sources of energy. We already mentioned some. We mentioned, let's see, hydraulic, pneumatic, and let's see, where's the other? Electrical. Electrical there, it's a big heading. So generally generated energy is what we're concerned about. That's what you get from the power company. But also static electricity could be a problem. In mechanical energy, there's transitional. I think I meant translational, excuse me. So forward motion, and then there's also rotational motion. Okay. Thermal energy is a big one. I was going through these slides a couple years ago with a student who'd been in industry for many years. He worked for a company that made glass. Now, they didn't make window glass. They made glass for like LCD screens. Okay, so this is very accurate glass, but it's still something that has to be melted. So it's a very high temperature melting thing. Okay. So anyway, so they have a lot of high temperature processes. He was actually interviewing for that company before he went to work for them. Let me correct myself there. He was interviewing and he ended up getting the job. But while he was there, a man got caught on some kind of conveyor or something that was pulling glass into the furnace. Okay, this was something that was hot, and ended up trying to drag him into the furnace. Fortunately, there were E-stops everywhere, so everyone hit an E-stop, you know. And the machine stopped, and they managed to get the guy out. He had burns on his back and things, but he fully recovered from what I understand. So it's a good thing they had E-stops. Now, this was just a machine that was running normally, right? So what got him was thermal energy, but that was an accident where thermal energy was misdirected. Think of it as heat. Those of you that have had thermo with me know that I just kind of messed with the terminology. But anyway, you can think of it as heat. Heat got it. Okay? Chemical reactions are another big potential source of energy. Okay? You guys remember a few years ago the sugar plant that exploded in Georgia. Remember that? There's a release of hazardous energy. It was a chemical reaction. Okay? Potential energy, we've already mentioned a few of these, but springs and gravity are two different sources. I've got to tell you one more funny story. When I worked for Amatrol, as engineers, we always tried to, we liked the riders, but we tried to, you know, be a little bit higher than the tech riders. But they were good people. But there was one tech rider that my boss was working with. It was a funny story. They were working on what's called a hydraulic trainer. This was a trainer for Ivy techs and people like that. That had a, you know, it had a pump motor on it. It had a couple of cylinders. It had some switches. It had a lot of standard hydraulic stuff laid out on the board so you can kind of see the system, see how it worked. Well, there's a device called an accumulator. How many people know what an accumulator is? Okay, well, for those of you that don't, an accumulator is basically just a tank with a spring, is how you can think of it. And as the pump is running, what it does is it essentially charges it, kind of like a capacitor for the ECET, but a really big capacitor. Now, in the process, what it does is it compresses the spring so that the hydraulic fluid that's in the reservoir is under pressure. Okay, that way, if the pump cuts out, there's a big call for load, right? There's a high flow rate needed for a short period of time. You don't have to oversize the pump. The accumulator can provide some of that needed power. Okay? It's a common device. Now, what's kind of interesting about it is that this device, this accumulator, when it's being charged, the charging process is not 100% efficient. Okay? In other words, you may charge it and there may be some energy stored in it, but what happens is the device heats up, and it heats up a lot. It can heat up so much that it can burn you if you touch it. So my boss wasn't thinking. He had just shut off the system, and he touches the accumulator for some reason. He goes, ah, it's hot. And the tech rider goes, Ah, you're right. So anyway, that wasn't really hydraulic energy that was misdirected as much as it was thermal, but hopefully give you the idea. Another thing you have to think about, if you have an overhead crane and the crane is shut down for emergency, do you want it to just drop the load? Probably not, right? You want it to hold the load. If it drops the load, it could drop it onto someone, right? So you got to think about those things when you design a system and decide how is failing safe, right? How do you want to fail safe? Okay, different types of lockout devices. You've probably seen this. This is probably the most common, most used, because electrical panels are so common, right? They're used everywhere. And usually that's where most of the energy we use in industry comes from, depending, of course, on what industry you're in. There's some industries like people who make ceramics and tiles and things, they use a lot more natural gas as a source of energy, but electricity is very common. So these are very common lockouts. Now what you'll notice is that a hasp is used so that multiple locks can lock out or block the flow of hazardous energy. Okay? The reason for that is because it's common to have more than one person working on the machine that's been locked out. And each person needs their own lock. And the way these are set up, you can actually put another hasp on this hasp in one of the locations and have plenty of room for as many locks as you need. Okay? But there are other devices as well. You can't see it because of the resolution up here, but these are two different plugs, just plugging into wall outlets. And the lockout device is simply a clamshell that closes around it and you put your lock on. Okay? That just means it can't be plugged in. Okay? Here's a device for a hand valve. Okay? If you ever get the chance to go on the tour, I'm trying to think. I know a few of you guys have been in 220 with me. Those of you that have been in 220 with me, did you go and visit the power plant on the river? Any of you been to that? A couple of you? Okay. Well, anyway, if you go to a place like that, you'll notice that there are tons of hand valves everywhere. Okay, so how do you lock out a hand valve? Because a hand valve allows flow, and that flow could have a lot of energy in it. So how do you block it off? Well, this is another clamshell device that just goes around the handle and locks, so that if you turn the clamshell, it doesn't turn the handle. You can't open the valve. It's another simple idea. What else? Well, there's a couple of different devices. Both of these do the same thing. Basically, the end of the air hose, the part that plugs in, the male end, is held in either one of these devices and can't be removed. And this device, it goes in, you put your lock around here, it prevents extraction of the coupling or the fitting. And so you can't plug it in, you can't pressurize the system. This does essentially the same thing. Here's another box that you can either put electrical cords into or pneumatic lines. And there's even valves. This is a pneumatic valve that usually your main pneumatic source comes in here. And then the switch here is just an on-off switch that blocks the flow of air, the compressed air. And you can't see it in this picture. If you look at it on the slides on your screen, you probably can see it. But right here, there's a hole, and you can put a lock in that hole. That prevents the switch from being turned on. And so it's a built-in lockout device. So there's a lot of different lockout devices. That's just some of them. Tag out, on the other hand, is a little bit different than lockout. Tag out is something where the tag itself has to be respected because it does not mechanically block the release of hazardous energy. Tag out is something that you put on a machine that says, don't operate the machine. Okay? Now, you have to be careful. How many of you have traveled to another country? Anyone in here? Did you drive in that country? Yes. Okay. Did you ride in a car in that country? What can you tell me about the streets and the signs and everything there? They're very different from what we have here, aren't they? Okay. Depending on what country you go to, you may not really know what the sign means. Okay? Why not? How come you couldn't drive over there? Well, you didn't know what the signs meant, right? Why didn't you know? Because it's not something you're used to seeing, right? So in tag out, it's important that the tags always have the same look. That way people understand them just by glancing at them. How do you know what a stop sign means? You just know, right? You see the shape, the red sign, 8 sides, white border, STOP. You know what it means, right? You don't have to think and read it anymore. That's the way tags need to go. They need to be set up so that as soon as you see the tag, you know exactly what it means. Like I said, it has to be respected. It has to not degrade in the local environment. A lot of industrial environments have either hydraulic oils all over the place or water. Once again, when we went to the Ohio Falls Generation Station, it was built, I believe, back in the 20s sometime. And if you look at the paint on the walls, it's peeling off. Why? because they're sitting on the river and it's always humid there, okay? So, paint deteriorates. So whatever environment you're in, you have to have tags that are compatible with that environment and remain legible, okay? Okay, here's a typical lockout procedure. First thing you have to do is alert affected employees. What are affected employees again?
Ones who work on the door are going to work in the area.
Right, okay, good. You have to alert affected employees that power is being disconnected, and you're going to do lockout tag on those machines. And then you have to shut down the equipment by procedure. Now, you can't just throw the switch on most machines. Okay? A lot of machines have to be started up correctly and they have to be shut down correctly. It's not a good idea to take a plastic injection molding machine that's hot and has a lot of molten plastic in it and just turn it off. Because that molten plastic will harden. You're going to have a heck of a time cleaning the thing out. Okay? So you have to shut these things down by procedure, unless it's an emergency. Operate the equipment isolation controls. In other words, apply, that basically means throw the switch off. Put it into position so that you can apply your lock. So then you apply the lockout device, dissipate or restrain any stored energy. In the example of the injection molding machine, you have a lot of thermal energy there that has to be dissipated. Okay, so it's important to get rid of that thermal energy so you don't burn yourself. In the example of a hydraulic system with an accumulator, you have to bleed off the accumulator. Make sure that there's no hazardous energy stored in the machine. And then you have to verify that energy has been removed. The way you normally do this is you try to start the machine. You push the start button. And of course, if you've done everything properly, then you find it won't start. Now, sometimes you'll be surprised when the machine starts because there's a panel behind it you missed and still supplying power. Okay? And that's the whole purpose of step 6 is so that you can verify that you have indeed isolated the machine from power. All right. A lot of times when the equipment's being worked on, it has to be restarted temporarily, tested, either for testing, for positioning. So there's usually a procedure that goes along with that. And at the end of all the testing, after you're done energizing the machine, you have to go back through the lockout tag on procedure to turn the machine back off. Okay. Finally, to remove the lock, there's another procedure. Remove tools, non-essential items, ensure equipment is operationally intact, ensure all employees are safely positioned or removed from the area. The way you started, it blows up and nobody gets hurt. Remove lockout tag on devices, and unless there's an emergency, each lock has to be removed by the person that applied it. Why would that be?
To ensure that they have the machine while it's going someone else.
Good reason. There's another reason. That's a very valid reason. What else?
Accountability.
Yeah, but it's also along the lines of what you're talking about. Yeah, it's so that each person is aware that their lock has been removed. Right? We want everyone who was working on the machine to know the machine is now re-energized. Okay? One way of ensuring that is if each person that applied the lock removes their own lock. Okay? So that's important. Notify the affected employees the equipment's ready for use. So now these are generic procedures. Each company has their own flavors. But there are special situations also where servicing lasts longer than one shift. It's time to go home. What do you do? Does the guy that is going home leave his lock in place? Of course not. Right? The machine may need to be restarted. Work may be done on the next shift. So it's important that he remove the lock, but it's important that someone else put their lock on first. Whoever's going to take over working on the machine. Okay, so there's this handoff and overlap in time that's necessary to be built into the schedule so that people can hand off work. There are times when contractors perform service or maintenance work. Okay, they should have their own locks as well. Okay? So they have to know the company's policies and procedures and work all that out. There are times when the worker who applied the lock is not available. Okay? There are times when people get sick. Right? They have to go to the hospital. Or for whatever reason. When the worker who applied the lock is not available, but the lock has to be removed, then there's a procedure, there should be a procedure for that scenario as well. Verify the authorized employee is not at the facility. Make sure the person who applied their lock is simply not there. Make sure that all reasonable efforts to contact an employee and inform them that their lock is being removed, make sure that's done. Okay? And then the authorized employee has to be made aware that his lockout or tag has been removed before he can resume work and come back into the facility. Okay? All right. Now, a little bit of information. Don't try lockout tag out unless you've been trained on the procedures at the particular facility where you work. Okay, that's a big no. Never loan or share your lock, key, or combination with anybody else. Why? Because that's there for your safety. A lock and key is cheap. Human life is expensive. Always be sure all lockout devices are compatible with the environment that they'll be used in. You don't want your lock to rust off and you don't know. Any questions? All right, one thing I like to do, this is a 2-hour class, and one thing I like to do in all my 2-hour classes is give you a break at about an hour, okay? We haven't gone quite an hour yet, but let me go ahead and give you the break, and come back in about 5 minutes or so.